Hello friends, so welcome to this video lecture to discuss the multiple choice questions for chapter number 5, combustion in SI engine. So in this video lecture we are going to discuss the various multiple choice questions which is to be asked frequently in the university examination. At the same time we also discuss the explanation behind the correct option. Let's start. So first, the knocking in SI engine gets reduced. The knocking in SI engines get reduced. Options are by increasing the compression ratio, by retarding the spark advance, by increasing the inlet air temperature, and by increasing the cooling water temperature. These are the four options are there. So out of these four options, the second option, by retarding the spark advance, the knocking in SI engine gets reduced. So the knocking in SI engine gets reduced by retarding the spark advance. So explanation behind this, that the advancing the spark, if we advance the spark, so what happens? The burning gas is compressed. When the spark is advanced, the burning gas is compressed by the rising the piston, and therefore both temperature and pressures are increased, and thus the tendency to knock increases with advanced spark timings and decreases with retarded spark timings. So by increasing the spark advance, what happens? The piston, that rising the piston, the pressure on the piston, as well as it will going to increase the temperature. So by increasing this temperature and pressure, the tendency to knock is going to be increased. So the answer or correct option is by retarding the spark advance, the knocking tendency is reduced. Because by retarding the spark timing, the peak pressure and further it also peak pressure is going to be further down in the power stroke, and thus the magnitude of this pressure is lower. Magnitude of the pressure is to be lower. Now second, with increasing compression ratio, flame speed, options are increases, decreases, remains the same, none of the above. With increasing the compression ratio, the flame speed increases, decreases, remains same, none of the above. So the correct option is increases. So why increases? So higher compression ratio increases pressure and temperature of working mixture, and it decreases the residual gases. These favorable conditions reduce the ignition lag. Favorable condition means increase in the pressure and temperature. This favorable condition reduces the ignition lag of the combustion. Hence, less the ignition advance is needed. The less the ignition advance needed, and high pressure and temperature of the compressed mixture also speed up the second phase of combustion. It also speed up the second phase of combustion, and therefore higher the compression ratio have higher flame speeds. Have higher flame speeds. And let's discuss the third, desirable characteristics of the combustion chamber for SI engine. Desirable characteristics of SI engine for SI engines to avoid the knock. To avoid the knock is small bore, short ratio of flame path to bore, absence of hot surfaces in the last region of the charge, and last all of the above. So the correct option is all of the above. So small bore, short ratio of flame path to bore, absence of hot surface in the last region of the charge. So these all options are the correct options. So as we know that combustion chamber design is an important activity as it affects the engine performance and its knocking tendency. So higher power output, higher thermal efficiency, smooth engine operation, and reduce the exhaust pollutants are the important considerations or the requirements for the combustion chamber used for the SI engines. So all these design characteristics are very important for the combustion chamber used in SI engines. Now fourth, in SI engines, flame speed increases. In SI engine, flame speed increases first with turbulence, second with air-fuel ratio, third both A and B, and D none of the above. So correct option is in SI engine flame speed increases with turbulence as well as with fuel air ratio. Getting with turbulence as well as with fuel air ratio, and the correct option is C, both A and B. So as we know that the flame speed increases with slightly rich mixture. Flame speed increases with slightly rich mixture, and the flame speed is directly proportional to the turbulence, as turbulence plays important vital role. Getting turbulence plays important vital role. So it directly proportional to the turbulence, and as turbulence accelerates the combustion reaction, it increases the heat transfer to the wall, means it increases the heat transfer coefficient. And that way it increases the pressure. Getting the pressure is to be rises. So flame speed increases with increasing air-fuel ratio and with turbulence. Next, detonation in SI engine occur due to pre-ignition of the charge before spark, sudden ignition of the charge before spark, auto ignition of the charge after spark is struck, and none of the above. So the correct option is auto ignition of the charge after the spark is struck. Getting detonation occurs because auto ignition refers the initiation of the combustion without the necessity of the flame, in the absence of flame. Getting so the end charge of the combustion chamber, in the combustion chamber, it going to exceeds its auto ignition temperature, its self ignition temperature, and it remains for ignition time delay period at that position, and during which it causes the additional flame, and this additional flame is going to flow opposite to the main flame front. Getting, and these both flame front are collide with each other. It moves opposite to the main flame front, and that both are collide with each other, and it causes the detonation. So the correct option is auto ignition of the charge after the spark is struck. 6. Increase of pressure increases the self ignition temperature and the ignition and the induction period. Getting, increase of pressure increases the self ignition temperature and the induction period. So it is a false. Getting, it is a false. Increasing pressure is going to decrease the self ignition temperature. Getting, it going to decrease the self ignition temperature as well as it is going to decrease the induction period. So it is a false. So increasing pressure increases self ignition temperature and induction period. So the correct option is B, false. This statement is a false. So increasing inlet temperature increases, as we know that increasing this pressure increases overall pressure during the cycle, and at the higher pressure the end gas decreases the delay period, and which increases the tendency to knock. So for to avoid the detonation, to avoid the knocking, the high self ignition temperature is important. High or longer delay period is important. But with increasing pressure, it will reduces the delay period, otherwise reduces the self ignition temperature of the charge by some hot surface in engine cylinder before operation of spark plug is known as pre-ignition. It is known as auto ignition, pre-ignition, detonation, none of the mentioned. So the correct answer is pre-ignition. The ignition of the charge by some hot surface in engine cylinder before operation of spark plug is known as pre-ignition. So as we know that increase in the rate of heat transfer to the walls has yet another effect. Increase in the rate of heat transfer to the walls has another effect. It may cause local overheating, especially of the spark plug. It causes local overheating of different parts in the in the combustion chamber, especially the spark plug is there, different metal corners are there, as well as the exhaust wall is there. Getting? So there are different parts are there, especially it going to overheat the sparking plug. And pre-ignition is nothing but the ignition of homogeneous mixture of charge as it comes in contact with these hot surfaces in the absence of spark. Getting? In the absence of spark. So what are the hot surfaces in the engine cylinder? So when these hot surfaces are come in contact with this homogeneous air-fuel mixture, it causes the pre-ignition without the presence of the flame. Flame is absent. Next, the combustion in spark ignition engine is homogeneous, heterogeneous, laminar, none of the mentioned. So the correct option is homogeneous. So as we know that in conventional SI engine, the air fuel mixture is prepared externally in the carburetor. So this uniform air fuel mixture is to be supplied to the engine cylinder, and hence the combustion is homogeneous. Combustion is homogeneous. So correct option is A, homogeneous. 9. The swirl is rotational flow of charge within the cylinder about the axis. So whether this statement is true or false. So this statement is true. Getting? Statement is true. As swirl is rotational flow within the cylinder about the axis. Swirl implies an orderly movement of the whole body of air. Swirl means that is having ordered movement of the air, of the body of the air with particular directions of flow. Getting? With the particular direction of the flow. So the swirl is rotational flow of the charge within the cylinder about the axis. This statement is true. 10. Data dash consists of randomly dispersed vortices of different size which become superimposed into air and petrol mixture flow stream. So A, turbulence, swirl, quench area, none of them mentioned. So the correct answer is turbulence. So turbulence consists of randomly dispersed vortices of different sizes which become superimposed into air and petrol mixture flow stream. Getting? So turbulence is very much needed in case of petrol engines. So turbulence is required in SI engine. It implies the disordered air motion with no general direction of flow. Getting? Turbulence means disordered motion with no the general directions. It is exactly opposite to the swirl. Swirl is ordered motion with particular direction, whereas turbulence is disordered air motion with no general directions, and it breaks up the surface of flame front and distributes the threads of this flame front in the combustion chamber throughout the combustion chamber. So the correct answer is turbulence. 11. Abnormal combustion knock produced by the surface ignition in SI engine is not harmful as normal combustion knock. So this statement is true, as the normal combustion is having the high pressure rise compared to the surface ignition like pre-ignition or this surface ignition. Getting? So the abnormal combustion due to this surface ignition or pre-ignition is less harmful compared to the normal combustion, as in the normal combustion the pressure rise is very much high. Getting? Compared to this surface ignition. 12th, in SI engine ignition lag is reduced if the initial temperature and pressure are. In SI engine the ignition lag is reduced if the initial temperature and pressure are decrease, increase, constant, none of the mention. So the correct answer is increase. So as we know that by increasing the initial temperature and pressure, the combustion temperature increases, and when the combustion temperature increases, the delay period reduces. This ignition lag is reduces. Correct. So in SI engine ignition lag is reduced if the initial temperature and pressures are increased. Next, low engine speeds will give low turbulence. Low engine speed will give low turbulence and low flame velocities, and knock may occur at low speed. So whether this statement is correct or false, true or false. So the statement is true. Low engine speeds will give low turbulence and low flame velocities, and may occur at low speed. So statement is true. So as we know that turbulence is required in SI engine. Turbulence is very much important in SI engine. Turbulence plays important vital role in SI engine. So turbulence of the mixture increases with increasing engine speed. Turbulence of the mixture increases with increasing the engine speed. So flame speed almost increases linearly with the engine speed. Flame speed also increases linearly with the engine speed. Turbulence increases directly with the engine speed. Flame speed linearly increases with the speed. For example, if the speed is double, the flame travel distance is half. Flame travel distance becomes half in the combustion chamber. Getting? So low engine speed will give the low turbulence. Getting? Because turbulence is directly proportional to the engine speed. Low flame velocity is also due to the low engine speed because it is linearly proportional with the engine speed. So the correct, that is a true. This statement is a true. Next, use of low octane fuel can eliminate detonation. Use of low octane fuel can eliminate detonation. Statement is a false. Statement is a false. Getting? Low octane fuel is going to increase the detonation. Getting? In actual, it increases the detonation. So as we know that tendency to detonate, tendency to knock depends upon the composition of the fuel. Getting? Tendency to detonate or knock depends upon the composition of fuel. So the property of fuel which describes how fuel will or will not self-ignite is called the octane number. Getting? The property of the fuel which describes how fuel will or will not self-ignite is known as octane fuel. Getting? So the lower the octane number means it has less tendency to knock. Lower the octane means less tendency to knock. The resistance to knock is a lower in that case. Getting? Resistance to knock is a lower. Higher the octane number, then resistance to knock is a higher. Next, the function of quench area in the vase-shaped combustion chamber is improve the compression ratio, cool the end gas, decrease the volume of combustion chamber, increase the volume of combustion chamber. So the function of quench area is going to cool the end gas. It is. So quench area, that is the additional areas, means these vase shape are going to provide the additional areas in which during the compression stroke the air fuel mixture is to be force. Air fuel mixture is to be catch in this vase shaped area, and this air fuel mixture is becomes the cool in this area. It becomes the cool in this area, and these vase shaped these areas are known as the quench area. Meaning, so scavenging process is the replacement of combustion products in the cylinder from previous power stroke with fresh air charge to be burned in the next cycle. So the statement is true. So what is scavenging? Scavenging is nothing but the clear the engine cylinder. Getting? So in the scavenging process, we are going to replace the combustion products in the cylinder from the previous cycle. Getting? In the previous cycle, during the power stroke, whatever the combustion products are there, they are to be replaced with the fresh charge to be burned in the next cycle. So scavenging means clear the engine cylinder. The statement is a true. 17. So increase the compression ratio in SI engines, the knocking tendency decreases, increases, not affected, none of the above. So the correct option is B, increases. So as we know that in increasing the compression ratio increases the temperature and pressure, and increasing the pressure and temperature increases the combustion temperature, and thereby it reduces the delay period. Getting? It reduces the delay period, and the delay reduces is going to increase the knock tendency. Getting? It increases the knock tendency. So increasing the compression ratio, knocking tendency increases. Next, SI engines are not generally supercharged engines. Statement is a true. So as we know that in SI engines the supercharged engines, means we are going to increase the pressure at the inlet, we are going to increase the density of the air at the inlet. What happens? It going to decrease the delay period. Is directly going to decrease the delay period, and decrease the delay period increases the chances of knocking. It increases the tendency of knocking, and because of that, generally it is now the supercharged engines. Next, by making the mixture too lean or too rich, tendency of knocking decreases. The statement is true. Statement is true. So the most important effect of the air fuel ratio is at reaction time, is on reaction time or on ignition delay. So the mixture is too lean or too rich, so it directly going to be effect on the reaction time, on the ignition delay. So when the mixture is slightly rich, then the stoichiometric mixture, then the delay period is a minimum. When the mixture is slightly rich, then the delay period is a minimum, delay period is a lower, and it causes the knocking tendency. Because of that, to avoid the too lean or too rich mixture is to be used. So by making the mixture leaner or richer, the tendency to knock decreases. Tendency to knock is to be decreased. Generally or especially a too rich mixture is to be used. Too rich mixture is to be used to eliminate the knock due to longer delay period and due to lower temperature of compression. Due to lower temperature of compression. Next, decreasing atmospheric humidity. Decreasing atmosphere humidity, the tendency to knock decreases. Decreasing the atmosphere humidity, the tendency to knock decreases. Statement is true or false. So it is a false. Decreasing the atmosphere humidity, the tendency of knock decreases. So this statement is a false. So as we know that the humidity also plays the important role along with the air fuel ratio, along with this composition factor. So increasing the atmospheric humidity, the tendency to knock, by decreasing the reaction time of the fuel. So if humidity is increases, tendency to knock decreases. Because it decreases the reaction time of the fuel. It reduces the reaction time of the fuel. Next, large engine size decreases knocking tendency. Large engine size decreases knocking tendency. So again, this statement is also false. Large engine size increases the knocking tendency. Large engine size increases the knocking tendency. So as we know that there is some limitations to use the large size engine in SI engine, to use the higher compression ratio in SI engine. So engine with similar design, generally runs at same engine speed, with the same engine speeds, but there are some limitations to use the large engines in case of SI engine, because it will going to increase the knocking tendency, and because of that there is some limitations with us to use the large size engine in case of SI engines. Large engines have greater knocking tendency, because again it increases the flame, requires the longer time. As large engine size is means flame travel distance also more. Flame travel distance is more, time also requires more. And because of that there is some limitations to use the large size engines, and that's why in SI engines they are limited to 100 mm. Next, the quality of petrol fuel is expressed in octane number or cetane number, API gravity or ACE rating. So it is expressed in the octane number. So in case of fuel rating for SI engine, octane number is to be used for fuel rating or knock resistance. Octane number that will describes us how fuel will or will not self ignite. How fuel will or will not self ignite. So that will defines the octane number. Next, pre-ignition is caused by the spontaneous combustion of the mixture before the end of the compression stroke and is due to cylinder walls being too hot, overheated spark plug points, red hot carbon deposits on cylinder walls, or D, any one of these. So the correct answer is any one of these or all of these. Meaning, so as we know that pre-ignition is initiated by some overheated or projecting parts, for example spark plug electrodes, exhaust wall head, metal corners, protruding cylinder head gaskets, etc. Getting, so these are the different that hot surfaces due to the auto ignition in previous cycles, it becomes these surfaces hot, and because of that the pre-ignition is going to be occurs in case of SI engine. Next, spark ignition engines fuel in order of decreasing knock tendency. Fuel in order of decreasing knock tendency. A. Paraffins, aromatics, naphthens. B. Paraffins, naphthens, aromatics. C. Naphthens, paraffins. D. Naphthens, aromatics, paraffins. So the correct answer is paraffins, naphthens, aromatics. So paraffin series have maximum tendency to knock. Aromatic series is minimum tendency to knock. Naphthens is having in between these paraffins and aromatics. Naphthen series comes in between the paraffins and aromatics. So next, which fuel has maximum resistance to detonation? Toluene, benzene, isooctane, N-heptane. So isooctane is having the maximum resistance to detonation, as isooctane having the higher octane number, that is 100 octane number, having the higher knocking tendency to the detonation. Next, in spark ignition engine supercharging, increases knock tendency, decreases knocking tendency. There is no effect on knocking. Knocking is affected by other factor. So as we know that in SI engines are not generally supercharged engines, because by increasing the inlet air pressure, it increases the density of the air and it is going to reduce the delay period, it is going to reduce the ignition lag period, due to which it increases the knocking tendency. So in SI engines, supercharging increases the knocking tendency. Next, which of the one of the following statement is incorrect? Which of the following statement is incorrect? Combustion is the process of heat liberation. Combustion is a chemical reaction. Combustion is a rapid oxidation. All of the above. Getting? So all these statements are correct. Next, a fuel of octane rating 85 matches the anti-knock quality of the mixture consisting of. The fuel of octane rating 85 matches the anti-knock quality of mixture consists of 85% petrol plus 15% diesel, 15% petrol plus 85% diesel, 85% heptane plus 15% octane, 85% of octane plus 15% of heptane. So as we know that the octane number is having the mixture of isooctane and N-heptane, getting by volume. It is a mixture of isooctane and N-heptane. So the correct answer is 85% of octane and 15% of heptane. Normal heptane means 85% of this octane, isooctane, and 15% of this normal heptane. Next, which of the following can have octane rating of more than 100? So benzol is having octane rating more than 100, as benzol is having the benching in their composition, so it having the more than 100. So these are the different multiple choice questions which are frequently asked in the examination point of view. So you can go through all these MCQs. Also there are so many other MCQs also we are having with us. We also go through this and attempt the quiz.